Hello and welcome to the NPL Defect of the Month. My name's Bob Willis. Now this month what I'd like to talk about is head-in pillow or head-on pillow. Regardless of what you want to call it, and I'm sure there are lots of other terms used in the industry, the important thing is to understand some of the reasons for this particular phenomena. Basically, when a solder joint reflows and the solder paste reflows on an area array package, both the solder paste and the solder ball, if it's a eutectic material, should join together, coalesce to form a perfect solder joint. But when you've got this particular type of defect of head-in pillow or head-on pillow, you get an open connection or an intermittent connection, as shown in these photographs. Now, the reasons that this may occur. Well, one can be the warpage of the component going through the reflow soldering process. If the printed circuit board remains flat and the package warps, then some of the terminations may not be in contact with the paste for the full length of the reflow cycle. The paste reflows, but the surface of the solder oxidizes, as does the ball. And you're bringing those two surfaces together as the package tends to flatten out, and perhaps that's the reason why a joint won't form, because the oxide forms on those two surfaces. Now, of course, paste manufacturers have developed better products to withstand the vigors of lead-free reflow and to reduce the possibility of the fluxing material degrading till right to the end of the process, hence giving us better wetting. So that's one reason. Other reasons for this particular type of defect, perhaps the alloy material on the spheres is different to what you're actually using in your solder paste. Now, a few degrees difference in the liquidus temperature of a solder ball theoretically shouldn't have an impact, but if you've designed your process to be so close between reflow and liquidization of the ball for forming a joint and getting the materials to coalesce together, perhaps that's the problem. So understanding the problem is particularly important, and what I always recommend is to do process simulations, because if you can show a defect happen, create the situation so you can observe it happening on your product and your board, then theoretically you can change a process parameter and see the impact. And it's not that difficult to do. Process simulators are available in the industry to allow you to watch reflow in X-ray as well as optically, or alternatively you have a reflow simulator in most manufacturing facilities today. It's called a rework process, and all you need is a video camera and a specific lens to aid the magnification, and then you can do your own process simulations and watch reflow take place and possibly actually capture head-in pillow or head-on pillow yourselves.